So graphing a circle is going to be a pretty simple part, right? You just have to find where the center is, figure out how far away, so what your radius is, and you just draw the circle in. Okay? So what we need to focus on is what our standard form is, and then from our standard form, how we know what the center and what the radius is. So the circle, I put the definition up here, but this is really something you should know. It's a set of all points equidistant, which is the radius, from a given point, which is the center. That's something you learned quite a bit about in geometry, either last year or if you're in it this year, you're learning about circles right now. And so we are going to have a standard form. So standard form for a circle is x minus h squared plus y minus k squared equals r squared. Now what's similar about this from our parabola equation? The h and k. When we had a parabola, what did the h and k stand for? The vertex, yep, your x and y point. So here for a circle, your h and k will stand for the center. Okay, that's where you would start your circle off, is you'd have to know where the center is. What do you think r squared, what do you think the r stands for? Yep, the distance away from the center, which would be the radius. So r is the radius. Okay, so if we know the radius and if we know the center of the circle, we can write the equation. So that's actually what we're going to do first, is I'm going to give you some information about the equation, and then we want to write it. So we need to figure out what the center is and what the radius is. So first one, we want to write an equation for a circle if the endpoints of the diameter are 5, 4, and -2, -6. So we're given endpoints of the diameter. So we're going to have to think about what we know about circles. Okay. So what is the diameter of a circle? What is that representing? I saw a whole bunch of you motion to it. You went like this. So what does that mean? Like all the way across the circle. And it's got to go through the center. Okay, so that would be like our diameter. So here I know the endpoints of the diameter. If I know the endpoints of the diameter, how can I find where the center of the circle is? Half of the diameter. So the point in the middle? Well, what formula could we use to find the point in the middle? The midpoint formula, which is conveniently still up on the board for us. So we would want to use the midpoint formula, which is you add your two x's together. So x1 plus x2, divide that by 2. And then y1 plus y2, divide that by 2. Okay, so if I want to find the midpoint here, in hopes to find the center, my x points are 5 and -2, so I would do 5 plus -2, and then I want to divide that by 2. My two y points are 4 and -6, so 4 plus -6, and I want to divide that by 2. So 5 plus -2, what's that? 3, so this becomes 3 halves. 4 plus -6? -2, so we have -2 over 2 becomes -1. So that is our center. There we go. We have the center of 3 halves, -1. So what does that represent in our equation? Which part? The center, the HK, right? So already in standard, we could start writing this out in standard form. X minus h. So that's going to be your x value. So that would be x minus 3 halves, yep, squared, and then plus y minus k. So what's our y value there? Good, so y plus 1 squared equals, now we just need to find the radius. It's y minus k here, and our k is -1. So y minus a -1 would be plus 1. Now, what's the radius on our circle? Where is that from? It's the distance from where? From the from the center to the edge. That's our radius, and it's the distance. So do we have a point for our center?
Yeah.
Yep. And do we have a point on the edge of the circle? And we have two of them, so we can choose which one we want to use. So we can use our distance formula. x2 minus x1 squared plus y2 minus y1 squared, the square root of that. Or you can think of change of x squared plus change of y squared. Take the square root of that. Doesn't matter to me which one you think of. You can get the same answer in the end. So does it matter which point you use? Okay, so which point do you want to use with the center? Okay, so we'll do the distance formula between 5, 4, and 3/2, -1. Okay. Which formula would you guys prefer to use? The first one, the long drawn out one? Okay. So distance is x2 minus x1. So here we'd have 5 minus 3/2. We want to square that, plus y2 minus y1. So 4 minus -1. We're going to square that. So 5 minus 3/2. You have a question, Josh? What? No. No, as long as you do the same order for both of them, it doesn't matter which one you do first. So 5 minus 3/2, what does that end up being?
It would be 3.5.
3.5, okay. So that's 3.5 squared plus 4 minus -1. 5 squared. Okay, what's 3.5 squared? So that's 12 1/4.
Yeah.
So 12 1/4 plus, what's 5 squared? 25. Okay, what's 12 1/4 plus 25? 37 1/2. 37 1/4. So our radius is the square root of 37 1/4. Now, our formula says it's equal to r squared. So if our radius is the square root of 37 1/4, what would r squared be? Just 37 1/4. Because if we square the square root, well, this in our formula it says it's equal to r squared. So our radius is the square root. We need to square that, so our square root then goes away. Okay, is that okay? All right, let's do another one where we have to write the equation. So write an equation for a circle if the center is at -4, -3, and it's tangent to the x-axis.
That means it touches it it's just touching.
Good. So yep, the word tangent, remember, means it just touches it one time. Okay. So this might be a good idea to just draw a little diagram to see what's happening here. So -4, -3 be right there for the center. Which one's the x-axis? The one going like this. So right here. So that means our circle has to just touch right there. So what would our radius be? From there up. So 1, 2, 3. So that tells us our radius is 3. And we have the center. So can we write this as an equation right away? Yep. Okay, so x minus h squared. So what would that be?
Wait, -4 would it be?
Yep, hk would be -4, -3. So x plus 4 squared. Plus y plus 3 squared is equal to, this is equal to r squared. So what would that be? 3 squared is 9. So there's our standard form. Is that okay? What? We got the radius by drawing this little diagram out. We plotted where the center was. And then we saw that this was tangent to the x-axis, so it had to just touch it once. So we go up here. We look, oh, if it touches the x-axis just once, that's right here. So we counted our radius to be 3. Okay. So now let's do some graphing of these. So I'm going to give you the equation. We're going to find center and the radius and graph it. We got the radius to be 3, so the 9 was 3 squared, because the standard form is r squared. All right, so we'll do one that doesn't involve completing the square first, just so we have the graphing portion down, and then we'll do a couple that involve completing the square. So write in standard form, find center, radius, and graph it. So first equation, x squared plus y squared equals 16. This is already standard form, okay? So that is standard. So where's the center if this is standard form? Yeah, the center is at 0, 0. And what's the radius? 4, good. How do you get 4 from the 16? Yeah, we have to take the square root of it. So to graph it then, you put your center at 0, 0. Your radius is 4, so you go out 4 in the 4 directions, up, down, left, right. So you go out 4, so 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, and 1, 2, 3, 4. And you just take those 4 points, and you're going to try to make the best circle you possibly can make without making it look like a diamond. Sometimes I find if you just keep going around in a circle, it starts looking better. You laugh, but it's true. Look at that. Circle's getting better and better the more times I go around. There we go. Okay? All right? The only thing, I'm not going to be picky about your circles. I just don't want to see this. Okay? I don't want to see that. I want to see an attempt at a circle. Okay? I don't want to see just drawing straight lines between the points because we know a circle has a beautiful curve in it. Okay? Is that okay? All right. So let's try one then that we have to do completing the square for to get it in standard. X squared plus y squared plus 6x minus 7 equals 0.
Should we add the 7 to the other side?
Perfect. We should add the 7 to the other side first. And then we also want to get together our like terms. So we want to get our x squared and our x together. And if we had a y, we'd want to collect that with the y. So we're going to put the x squared plus the 6x together. Leave a blank spot to complete the square. Plus y squared, there's no other y. And then we added the 7 to the other side. Okay, right. So now we take a look at our parentheses and we go, okay, now we need to complete the square here. So what would we have to add here? Perfect. Divide the 6 by 2 and then square it so we get plus 9. Now we want to, okay, so on the same side of the equation we would do minus 9, right? But do we want any other numbers over here? No. So what could I do to the other side of the equation? I could plus 9. Okay, that way I'm keeping the equations the same. I added 9 to both sides. Do I have to times this 9 by anything? No, because there was no number in front of the parentheses. So what do we have then? X squared plus 6x plus 9 becomes what? Good, so x plus 3 squared plus y squared is equal to, good, 16. Standard form. So where's the center of our circle for the standard form? Yep, negative 3, 0. And what's the radius?
Why is that 0?
4. This is 0 because there's no number here attached to the y squared. It's not.
Wouldn't it be 1?
Nope, there's no number being added or subtracted to the y, so that would be a 0 point for your k. Okay, so then to graph this, where would we go first? Yeah, put your negative 3, 0, your center on there, and then just go 4 out each way. And then draw the best circle you can make. There we go. Okay, starts looking more like a circle the more times you go around. Is that okay? Well, my circle's a little iffy, I know that, but the process okay? All right, let's do one more then where we have to complete the square. X squared plus y squared minus 4x plus 8y minus 5 is equal to 0. Okay, good. So the 5 has to be added over to the other side. And then what else should we do in the same step? Yep, get your x's together and get your y's together. So x squared, what will go with the x squared? The minus 4x. Yep, we'll leave a blank spot because we know we're going to want to complete that square. Plus, and then the y squared, what will go with the y squared? The 8y, good. We'll leave a blank spot because we'll want to complete that square. And then what should this be equal to? 5, good, because we added the 5 over. So now we have to complete both of these squares.
So this time because you have the 8y also?
Yep, because we have the 8y also. So now we have 2 different squares that we need to complete, which means we are going to add on 2 different numbers to the other side. So yeah, this first one, 4 is our middle number. So yeah, we add 4. 4 divided by 2 is 2. 2 squared is 4, which means on the other side we are adding 4. Okay, now for the y's, our middle number is 8. So yeah, this would be 16. Divide 8 by 2, you get 4. 4 squared is 16. So then over here, I should also add a 16. Okay, so now what do we have? Well, that was a little strange, x. Try again. All right, so what's our equation? Well, this first one be x. Good, x minus 2 squared plus, what will our y's be? Yep, y plus 4 squared is equal to 25. So here's, we got the x minus 2 because this x squared minus 4x plus 4 would factor to x minus 2 times x minus 2. So where would the center be at? Positive 2. And then what? Negative 4, good. And the radius would be 5. So there's our standard form, our center, and our radius. Okay, so then we graph 2, negative 4.
So you find the radius by
This is
the square of 25.
square root of 25, yeah, because the radius is r squared in your formula.
Could you ever have a number that's not like a perfect square?
Yeah, we could have a number that's not a perfect square here. So say if we had like 30, Square root of 30 is about, I don't know, 5.4 or so. So you just go a little bit more than 5. Yeah, just estimate it. So here's our center. So we'll do a radius of 5 each way. Ooh, I'm off my graph a little bit. If you're ever off your graph, this isn't off by a lot, so it's okay. But if you end up going really far off your graph, you can move your x and y axis around. You can shrink your graph, so you can go by 2s or by 4s. Anything like that's fine. You can just draw it off of it too, as long as you're not too far off. Well, that really didn't hit the mark. This is a pretty hideous circle. I apologize. If I had an eraser, I would erase that and start over. Yeesh. That's a bad circle. But it doesn't look like a diamond, so we're okay. That's okay? All right.